So the second factor affecting the chemical composition of milk is environmental factor. So environmental factor I think considered different factors. First one is interval between milking, the feed issue, milking completeness are some of the important factors considering under environmental factor. So interval between milking, so the fat content of milk vary considerably between this morning and the evening milking. So there is a big variation in milk composition between morning and evening milking when the interval between milking session is unequal. So the milk yield cow less after short calving interval. Yeah, for example, within short milking interval, so the milk yield is less, but so the fat as well as the protein percentage is high because milk yield is inversely proportional to that of milk fat percentage. So the milk yield at morning milk higher than that of the milk yield in the afternoon. So because of this reason, so the milk yield, especially in the morning, the fat content is less. If the cow usually milked at 12-hour interval, so the variation in fat content between milking would be negligible. If we are following equal milking interval, so there is no such big difference in fat percentage, but this one is not applicable in most farm. So normally solid not fat content meaning the protein, lactose as well as mineral content does not vary with length of time between milking. So the influence of interval between milking, especially for the solid not fat content, is very minimal. So if we look at this table, so the milking interval and composition of Jersey cows affected by milking interval. For example, if we take, we do have 3 milking interval. The first milking interval is 5 hours, second one is 7 hours, the third one is 12 hours. So if you look at the milk yield, so in this milking interval, for example, if the milking interval is 5 hours, so the milk yield is 70 liter. 15 liter. Under 7 hours is 17 liter. When the interval is a bit lengthy, the milk yield is also increasing. So if you look at the fat percentage adjacent with each milk yield, so in this case the fat percentage is higher than 7 hours. So this one is by far higher than that of 12 hours. When the milking interval is increasing, the fat percentage is decreasing, but the effect is very minimal in case of solid not fat, meaning protein, lactose and mineral. So look, so milking interval has a huge impact on both milk yield as well as fat percentage, right? So this is how milking interval is affect both milk yield as well as the fat percentage. So when it comes to the water intake, so water is one of the most important nutrient required by dairy animal. So of course water may not provide specific nutrient, but this one is categorized under the 6 important nutrient because this is important for metabolism process. So if you look at the water intake, so lactating cow require 3 to 5 liters of water for each kilogram of milk produced. So in order to synthesize 1 liter of milk, so the animal require 5 liters of water. How water is important to synthesize or produce milk, because 1 liter of milk, in order to produce 1 liter of milk, 5 liters of water is required. So otherwise, so the milk yield is compromised because the milk is full of water. 7% of milk is water. So because of this reason, adequate amount of water is important to produce milk. So therefore, restricting the amount of water for dairy cow result in lower milk yield. So if we restrict so the amount of water means at the same time, so we limit milk production as well as the composition of milk, specifically fat percentage. So I think different research shows that cow having free access to fresh water produce 7% more milk. Look, we do have 7% more milk advantage, again 6% more fat advantage, when the animal water access is limited to only 2 to 3 times per a day. So even provision of water limited to 2 to 3 times is not enough. So free provision of water is important to have more milk as well as more fat percentage. So water intake is a very critical issue in terms of milk yield as well as in terms of milk yield as well as milk fat. So another important issue is feed. So if we look at the feed content. So if we look at the feed, so the first one is energy content. High energy intake usually result in higher milk yield. Okay, so in order to increase higher milk yield, so we need to be provide adequate amount of energy feed. So at the same time the protein content become high, but so this one is inversely proportional to that of fat percentage, because the amount of milk is increasing but the fat percentage is decreasing. So the other one is protein intake. So this one is another important nutrient required for dairy cow. So underfeeding protein affect both milk yield as well as the protein percentage of milk, especially during early lactation. So during early lactation, so the amount of milk production is high. So because of this reason, so animal require high amount of protein. So under feeding of protein, so affect both milk yield as well as the protein. So by increasing the protein intake, while maintaining energy level, so the protein percentage of the milk will be increased. So protein intake has also impact on the protein component of milk. So the response is, however, dependent on the rumen degradability of protein in the ration. So protein could be rumen degradable and rumen undegradable protein, especially for high productive animal. Rumen undegradable protein is very critical. So because of this reason, so to ensure a high protein percentage in milk, it is advisable that the ration should contain at least 4% of non-degradable protein. So non-degradable protein is very important, especially fish meal as well as this oil feed. So especially these oil cakes are important. Concentrate feed provide protein. So the other one is fat supplement. So including rumen protected fat in the ration usually increase the fat percentage of milk. So rumen protected fat is very important to increase the percentage of fat. So in general, whether it could be protein or fat, it has also influence on the fat percentage as well as the milk protein content. So the level of dietary fat especially exceed about 7%, so the milk fat percentage and protein content may be decreased. So we don't have any special advantage when the level of dietary fat is beyond this 7%. So it has also another implication. For this time it is not such necessary. So all fat and oils, particularly unsaturated fatty acid like soya and maize oil included in the ration high in concentrate decrease the fat percentage. So I think this is how fat supplements are affecting the chemical composition of milk. So another important factor affecting the chemical composition of milk categorized under feed is sulfate to concentrate ratio. So one the big umbrella is environmental factor. So the concentrate to roughage ratio is very critical because this one discrete effect on the ratio of acetic to propionic acid produced in the rumen. So this one is very critical. For example, the end product of rumen fermentation is there are three important volatile fats. The first one is acetic acid, the second one is propionic acid, the third one is butyric acid. So this acetic acid is very critical because this one is the precursor of milk fat. Okay, so milk is synthesized from this acetic acid, which is produced when the fiber is digested in the rumen. So in general, there are three different volatile fatty acids which is produced from result of this rumen fermentation. Acetic acid, propionic acid, and butyric acid. Especially propionic acid and butyric acids are very important for synthesis of lactose and protein. So at the same time, it can contribute the milk yield. So propionic acid is derived from degradation of carbohydrate and promote synthesis of lactose, which encourage milk production. So this is this volatile fatty acids are very critical. Anyways, in general, the three volatile fatty acids, which is end product of rumen fermentation, contribute 70% of energy. But we are not feeding the animal, we are feeding the microorganism inside the rumen. Okay, so these microorganisms are responsible to produce such volatile fatty acid. So that one is important source of energy for dairy cow. So at the same time, it's also important for synthesis of milk fat as well as synthesis of protein and lactose. So I have already mentioned it. So propionic acid serves as important source of energy during synthesis of protein by rumen microbes, so resulting higher protein level in milk. So propionic acids are so important for to increase the protein level in milk. So ration containing high concentrate level increase milk yield as well as the protein percentage of the cow, while the diet with high in fiber increase milk fat percentage because the precursor of synthesis of fat is acetic acid, so the acetic acid is end product of this fiber diet. So if we look at this table, so the effect of roughage to concentration on the yield and fat percentage of milk, and with the ratio of this roughage to concentrate ratio is affect. First one is milking, the second one is fat percentage. So if you look at the ratio between the roughage and concentrate, what's different proportion of this roughage and concentrate? For example, if we take our proportion 45 to 55, meaning the roughage is 45%, the remaining is concentrate, which is around 55, so the milk is around 24 liters, the fat percentage is 3.5. So when the roughage is increased to 60, while the concentrate is reduced to 40, so the milk yield is decreased, but the fat percentage is increased. When the roughage is kind of dramatically increased to 75, while the concentrate is dramatically decreased to 45. So the milk become reduced while the fat content become increased. So anyways, from this table, we can conclude that when the roughage diet is increasing, the fat percentage is increased while the milk is decreased. So the other important point is the physical structure and quality of roughage. So this one is another important factor affect the chemical composition of milk. So finally, ground and pelleted roughage move through the rumen at faster rates than long particle hay. When the length of the particles of the hay is increasing, so it will hold for a couple of hours in the rumen. So that one is important to produce more saliva. So that one is important to make stable rumen pH. So that favor growth and multiplication of microorganisms responsible for fiber digestion. So anyways, especially the ground size is less than 2.5 centimeter. So they are easily digested in the rumen at fast rate, so that one may not ensure production of saliva. So saliva is very important to make the rumen neutral pH, so that one is favors the growth and multiplication of bacteria responsible to produce fiber diet. So this end product of this fiber diet is acetic acid. So acetic acid is the precursor of milk fat. Anyways, feeding a small quantity of underground and coarse hay may also improve or reverse the situation. So feeding ravage contain high levels such as Alica silage and hay increase in milk yield and that of protein yield. So anyways, milk yield, fat as well as protein percentage may increase when the ravage is fed as a silage instead of hay. So because forage crops are usually harvested at earlier in case of silage and that of hay. So this increases the energy content of the ravage while maintaining its fiber content, which is more digestible as it contains less cellulose and lignin. So because of this reason, it increases milk yield, fat, as well as protein percentage. So anyways, generally underfeeding reduce both feed and underfeeding reduce both the fat as well as solid node fat content of milk, but solid node fat content is more sensitive for this feeding level, but the fat content is more sensitive to that of the ravage diet. So because the precursor of this fat content is this ravage diet. So the other one is completeness of milking. So this one is also another factor categorized under this environmental factor. It is well known that fat content of milk increases continuously during milking process, even in milking process. So there is a variation. So the first drop of milk contain small amount of fat, while the last milk or strip contain amount of fat, which is around 8.7%. Sometimes go beyond this percentage. So thus it is essential to milk the cow completely. It's very critical to have a representative sample and thoroughly mix all the milk removed before taking a sample for analysis, especially those who are on the way to do research related with milk composition. So complete milking followed by mixing is very critical to get the right chemical composition information. So the fat left in the udder at the end of milking is picked up during subsequent milking, so there is no net loss in fat. I think we can capture the coming day, but especially those who are doing research probably generate false data, but so there is no net loss of fat because it can be harvested in subsequent milking. So the soil fat content estimated as a proportion of the fat-free part of milk, does not change during milking process. And with completeness of milking, there is no association between solid node fat content, right? As that of milk percentage. So milk yield loss due to incomplete milking, especially high producing cow, are normally not fully recovered. Especially high producing cow such. So this is also a very critical issue. So milk yield loss due to incomplete milking, especially high producing cow, are normally not fully recovered. So if you look at this table, the effect of stage of milking process at percentage of milk, especially the first 15% of milk, its fat content is around 1.9. So the middle between this first and last milking, which are 58% of the milk contain a bit high amount of fat compared with the first 50% of milk. So the last milk, especially the last 27% of milk contain 6.8. So on average, this cow produce 3.1 percent of milk fat. So how